All right, so again, our compound interest formula is A equals P times the quantity of 1 plus R divided by N to the NT power. A is your total amount, which is the A. P represents the principal, not like Mr. Sparks. I could have, yes. P is the principal, which means the initial amount. R is your interest rate, and that's as a decimal. So remember to go from a percent to a decimal, move your decimal 2 places to the left. N is the number of compounds per year. Compounds means how often you're getting your interest. So if you're getting your interest 4 times a year, compounded quarterly, you put a 4 in. If it's monthly, that'd be 12. So there's 12 months a year. It says per year. Number of years. So kind of. All right, so we have a couple examples. First one says Dave invests 300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years if the interest is compounded by the following frequencies. So I'm just going to extend this over, and I'm going to put the variables or give my givens over on this side that works for both, and then there's one that given that's specifically for A and one that's specifically for B. So one of the things that we know is our principal. What is the principal for this problem? 300. So P equals 300. We also know the rate. The rate is 5%, but how do we have to put it in? 0.05. We got to move our decimal 2 to the left. That's a 1. Okay. We also know the T, the number of years, is 15. And since there are 5 letters, we need 4 of them. So we have the P, the R, the N, the T, and then we can get the N from semi-annually and monthly. So if you're doing something semi-annually, how often do you do it? Twice a year. So N would be 2 for semi-annually, and for monthly, there's 12 months in a year. So the only letter we don't have is the A, and we can figure what that is just by plugging everything else in. So for our first problem, letter A, be A equals 300, parenthesis 1 plus R is 0.05 divided by 2 to the 2 times 15 power. So this is where we would then go and type that in our calculator. And you can type that whole thing in your calculator as long as you are careful. And so first thing we do is the 300, parenthesis, 1 plus. And then if you have a graphing calculator, you can use the alpha y equals to make it look like a fraction. So 0.05 over 2. And then close your parentheses in the exponent 2 times 15 power. And you should get 629.27. Now we're talking about money. So money is how many decimal places? 2. So therefore, you always want to look at the third decimal place. In this case, it's a 0, and 0 makes the second one stay the same. So $629.27. If you have like a scientific calculator like this, okay, you can still use it. You just have to be a little bit more careful when you type it in. You probably have to type it in like this: 300 parentheses 1 plus, and then parentheses again, 0.05 divided by 2. Close your parentheses twice, and then in the exponent, you need that in parentheses also. Again, you get the same answer either way. So we would get $629.27. Make sure you're practicing typing this in. Now, if we're doing B, which is monthly, the only difference is we're changing all those N's from 2's to 12's. And so if you have a graphing calculator, it's actually kind of easy because all you have to do is press second enter and it'll pull up what you just used last. So if I press second enter, it pulls up everything I just used. I just have to make sure I'm changing those 2's to 12's. You want to press second INS or second delete there so that it pushes everything over. And if you're on the bottom of a fraction, you can just retype 12. So I get $634 out 0.111. So I look at that third one, it's a 1. That keeps the second one as a 1 also. So you can see that how often it's compounding makes a difference. Because even though they both start with $300, even though they both have a 5% interest rate, the fact that it got compounded more times means you get more money. Okay? Because what you're getting is that the more times you get interest, there's more in your account, and then you're taking the percent of what's in your account. So it's creating a little bit more interest. And it should be close, but it's going to create a little bit more. The more often you do it, the more you're going to generate. All right, for number 2, if $2,500 is deposited into the savings account, earning 8% annual interest, how much would you have at the end of 25 years? And then we're looking at it as quarterly, and compounded daily. So again, the first thing we're going to do is figure out our givens. In this case, our principal is 2,500. Our interest rate is 8%, so we move that over to the left, 0.08. And we're keeping it in for 25 years. And then our N for letter A, if you're doing something quarterly, how many times are you doing it? Quarter is always 4. So N equals 4 for letter A. And daily, how many days are there in a year? 365 is your N for B. So for letter A, we'd have 2,500. That's our A. 1 plus our rate is 0.08 divided by our N, which is 4. And it's the 4 times 25 power. Yeah. No, the one's inside the parentheses. So parentheses 1 plus, and then you'd have to do another set of parentheses for the fraction. You should get 18,111. And now if we look here, it's 0.615. So this 5 is going to make the 1 a 2. So 18,111 and 62 cents. Yes, sir. You still did 300. 300 was the A for the last one. We're doing 2,500. You have to make sure your exponent is in parentheses also. So that was taking just the fourth power, and then you multiplied that answer times 25. You have to make sure when you're doing it, the exponent is in, 4 times 25. Or do 4 times 25 first, and then just put 100 in as the exponent. Okay? You got it, Missy? You good? All right. All right, so that means letter B would look like 2,500. 1 plus 0.08 divided by 365, and then to the 365 times 25th power. And again, we could just press second enter, changing second insert, second delete, changing that to 365. And on the bottom, we also have 365. Yes, I do. Thanks, Elias. I knew something was wrong when I got that huge answer. There we go. 18,468 and 59 cents. So again, should be relatively close, but you can see over 25 years, that's 300 over 300 more dollars. But it shouldn't be a ton. It shouldn't be like millions of dollars more. $18,468.59. All right, you're gonna try number 3 on your own, and just be careful what the question is asking you. So make sure you read the whole thing and answer what the question is saying. So again, your principal is in this case 750. The rate, 0.4 is the percentage. So you have to still move 0.4 2 to the left. So it's 0.004 is your R, and the time is 10 years. And so your equation would be A equals 750 times 1 plus 0.004 divided by 2. Okay, your N is 2 because it says semi-annually. And then that's raised to the 2 times 10 power. So that's the first thing you need to do. And if you do that, you should get $780.58. However, is that answering the question? No, the question is saying how much interest did they earn? You start with 750, you end up having 780 and 58 cents. So you have to subtract those two to figure out how much interest you earned. So $30.58 should be your answer.